In the last part of the homework, they're giving us some problems in which we need to find the area of a parallelogram, and they describe how to do that in the book. You can get the area of the parallelogram by taking the magnitude of the cross product of two adjacent sides. So they show that in the book, and they maybe prove that in the book. So we're going to take the cross product of two adjacent sides. That's going to be equal to the area of the parallelogram that's formed. So let's go do that. And so what I'm modeling here is also modeled in the book. They're telling us in 48 that there's two adjacent sides. One is P1, P2, and the other adjacent side is obviously including one of the points, and they choose P1, P3 as the other adjacent side. So we got to find those vectors first. So P1, P2, no problem. We're just going to subtract their x's, their y's, and their j's. So for P1, P2, it is the vector 4i plus j minus 3k. That's going to be the P1, P2 vector. And then for P1, P3, we would simply do 2 minus negative 2 for another 4i, a negative 1 minus 0, so minus j, and a 2 minus 2 for no k's. And I'll just put the 0k in there for emphasis. Some books will leave that out. So what do we have to do? Well, those are two adjacent sides, so we need to figure out their cross product. And so we do the I, j, k vector. Across the top, we have 4, 1, negative 3, and we have 4, negative 1, 0 coming into our determinant. So what is that? Well, that's simply, if we cross out the i's, that's 0 minus 3i minus, and if we do j's, 0 minus a negative 12 j plus, and then this last one would be negative 4 minus 4k. And so what do we end up with? We end up with the cross product vector negative 3i, and two negatives make a positive, but then there's a third negative out there, minus 12j minus 8k. And so that's our crossed vector, but that's not the area of the parallelogram. However, the cross product of the two would, or the magnitude of that cross product will be. And so what do we get when we take the magnitude of the vector negative 3i minus 12j minus 8k? Something easy. The square root of the first thing squared plus the square root of the second thing squared plus the square root of the last thing squared. So the I coefficient squared, the j coefficient squared, the k coefficient squared. And what do we get under there? We get the square root of 217, which is the answer.